A bird flies from a tree. At time t seconds, the bird's height, y meters above the horizontal ground, is given by this. Find dy dt. Find the rate of change of height of the bird in meters per second when t is 1. Determine with a reason whether the bird's height above the horizontal ground is increasing or decreasing when t equals 1. Find the value of d2y by dt squared when t is 2. And given that y has a stationary value when t equals 2, state whether this is a maximum value or a minimum value. So here's the question then summarized. Okay, so part A, I'll just put it here in part A to save some space. So differentiate this, it's 4 comes down, t to the 1 less, over the 8, minus the 2 comes down to be there, t to the 1 less, which is just 1, and the constant goes to 0. The 4 and the 8 cancel top and bottom, so it's t cubed over 2, isn't it? Minus 2t. So there's dy dt. Find the rate of change of height when t equals 1. So I'll squeeze it in here if that's okay. So dy dt is equal to, when t is 1, is 1 cubed over 2 minus 2 times 1, which is a half. Minus 2 is minus 1.5, or minus 3 over 2. The change in height in meters per second, wasn't it? The change in height is minus. So it means it's falling down because this is the height of the bird in the tree from ground level, presumably. Let's have a look at the question to see what the question said again. Height in meters above the horizontal ground. Yeah, that's right. So it's height, the rate of change, the velocity, so it's moving downwards here, isn't it? Is the height increasing or decreasing when t equals 1? Let's just put the reason first. So the height is decreased, isn't it? Since dy dt is less than 0. That's the rate of change of height with respect to time is negative, so the height must be decreasing. Find d2y dt squared when t equals 2. So let's get the second derivative now. Here's dy dt here. So d2, let's put it down below now then. So part C. So d2y by dt squared is equal to, differentiate this, the 3 comes down to the 1 less, which is squared over the 2, minus, and the t differentiates to 1, and there's minus 2 lots of 1, which is minus 2. That equals, put t equals 2 then, in here, 3 times the 2 squared over 2 minus 2, which is 4 over 2 is 2, 2 3s is 6, minus 2 is 4. And this is the meters per second. So this is the acceleration. When t is 2, it's got a positive acceleration. Given that y has a stationary value when t equals 2, state whether this is a max or min value. Well, clearly because this is positive when t equals 2, this is. So part 2. Y is a stationary value when t equals 2. State whether this is a maximum or minimum. So it's positive, so it's a minimum. And this is since the second derivative is positive when t equals 2.